Welcome to this deep dive. We're pulling apart the key ideas from some interesting new research today.
That's right.
We're looking at a pretty tricky problem in AI. How do we get large language models to give genuinely useful feedback on complex reasoning? Think tricky math problems.
Yeah, that's a real bottleneck.
And our sources today introduce something called DeepCritic. It's a new framework aiming to make LLMs much, much better critics.
The core issue, really, is that current LLM critics, well, their feedback is often a bit superficial. It's just not deep enough to really help another LLM figure out where it went wrong.
So they're not great at judging if a solution is actually correct.
Often no. Their accuracy in judging correctness, especially step by step, can be quite low because the feedback itself isn't, analytical enough.
Okay, so DeepCritic is meant to fix this. What's the main goal here?
Well, the mission, if you like, is to get LLMs to perform much more deliberate, really in-depth critiques, looking at each reasoning step carefully.
Right, moving past just a surface-level check to a proper step-by-step analysis.
That's the idea, a much more granular evaluation.
And the research threw up something a bit unexpected, didn't it? That DeepCritic, even though it's, well, relatively small.
Yeah, built on a 7B parameter model.
It can actually do a better job spotting errors in math reasoning than some of the really big players, like much larger models.
It seems so, yes. It showed stronger performance in identifying errors compared to even significantly larger models in the tests they ran.
Okay, how does it achieve that? You mentioned a specific training process.
Yes, the two-stage process. The first stage is called critique teaching.
Critique teaching, right. What does that involve?
So in this stage, they used a very powerful LLM Quen 2.572B instruct, a top-tier model.
The 70 billion parameters. Yeah.
They used that to generate a whole data set of really high-quality, step-by-step critiques for math problems.
High quality how? What makes them different?
Well, each critique wasn't just a quick judgment. It involved like an initial analysis, then checking that analysis from multiple angles, multi-perspective verification, they call it.
Okay.
And even a critique of the initial critique, sort of a self-reflection step.
Ah, so refining the critique itself to make sure it's solid.
Exactly. It builds in this quality check. Then they took this whole data set of detailed, refined critiques and used it for supervised fine-tuning of the DeepCritic model, basically teaching it the format and depth of this deliberate critiquing style.
Okay, so stage 1 teaches the how-to of deep critiquing. What's stage 2?
Stage 2 is critique incentivization. This part uses reinforcement learning.
Ah, RL.
Oh.
So rewarding the model for making good critiques, making it want to critique well.
That's the essence of it. They used RL to further sharpen its critique abilities, and the rewards were based on, well, they used two kinds of data.
Okay.
Either existing human-labeled data, they mentioned PRM 800K, which is a known benchmark with human feedback on math reasoning steps.
Right, using human judgment as the gold standard.
Or, and this is quite interesting, they also used automatically generated data.
How did they generate that automatically?
Using Monte Carlo sampling. Basically, they estimate the correctness of a reasoning step by sampling potential outcomes or solutions multiple times. If most samples lead to the right answer, the step is likely correct.
Okay, like running lots of mini simulations to gauge correctness? That sounds scalable.
It potentially is, yeah. It reduces the dependency on laborious human labeling.
So summing up the performance then, what's the headline?
The main takeaway is pretty striking. DeepCritic, remember, built on that 7 billion parameter Quen model.
Relatively small, yeah.
It significantly outperformed other LLM critics. That includes critics of the same size, but also, importantly, even giants like GPT-4o on several standard math reasoning benchmarks.
Which benchmarks were those?
They tested it on MRGSM8K, PRM800K, and Process Bench. These are all designed to test how well models can follow and evaluate reasoning processes, particularly in math.
And DeepCritic came out on top in spotting errors.
Yes, in accurately identifying incorrect reasoning steps.
That is impressive for a smaller model. Can we get more specific? What does its feedback actually look like compared to others?
Sure. The critiques it generates are just much more detailed, more insightful. Instead of just saying step 3 is wrong, it tends to explain why it's wrong, maybe pointing out the logical flaw or calculation error.
So addressing that shallowness issue we talked about at the start.
Exactly. And because the feedback is more specific, it's actually more useful for the other LLMs, the ones trying to solve the problem. It helps them pinpoint and correct their errors more effectively.
Better feedback leads to better learning for the generator LLM. Makes sense.
And another key point, it performed well even when trained just on that automatically generated data from the Monte Carlo sampling.
Right, you mentioned that. That suggests you could potentially scale this up without needing massive amounts of human effort for labeling.
That's the hope, yes. It points towards a more scalable way to create these capable AI critics, or what some call scalable oversight.
Okay, what else? Any other capabilities worth highlighting?
Well, they also found that using majority voting with DeepCritic boosts its accuracy even further.
How does that work? Just run the critique multiple times?
Essentially, yes. Get multiple critique outputs from DeepCritic for the same solution step, and then take the majority verdict on whether it's correct or not. It shows good test time scaling properties.
Multiple opinions leading to a more reliable consensus.
Mm-hmm. And perhaps the most practical application is using DeepCritic to directly improve the LLMs that are generating the solutions.
How so?
Two main ways. First, you can use DeepCritic as a verifier in a verified majority voting setup. Basically, generate multiple solutions, have DeepCritic check them, and only keep the ones it deems correct. It filters out the bad solutions.
Okay, improving the final output quality by filtering.
Right. And second, you can use its detailed critiques to actively guide the generator LLM to fix its mistakes. Like, here's where you went wrong, try correcting it this way. It's called critique-based refinement.
So it actively helps the generator learn and improve its reasoning.
Yes. And fascinatingly, they show that even the smaller 7B DeepCritic model could effectively supervise and improve the outputs of a much larger generator LLM.
Wow, so a smaller specialized AI acting as a better teacher for a bigger, more general AI.
Yeah.
That's quite something.
It really is. It suggests some interesting possibilities for how AI systems could evolve.
Definitely food for thought.
Yeah.
You know, if AI models can get really good at critiquing and improving each other's complex reasoning, well, what does that open up for automating learning, for tackling problems we currently struggle with? It's something to ponder.